All right, so today we're doing Chapter 13, Day 5, and you will need a graphing calculator for some of the example problems. All right, so the conjugate roots theorem says that if a plus bi is a root of a function, f of x equals 0, and all the coefficients are real, then a minus bi is a root as well. So those are considered to be conjugates of one another, a plus bi and a minus bi. Now, that's for complex conjugates. But there are also irrational conjugates. So if a plus b root c is a root of the function f of x equals 0 and all the coefficients are rational, then a minus b root c is a root as well. So those are irrational conjugates. All right, so going on to example 1, given one root, find the other roots of the equation. They give you this fourth degree polynomial. We know that there should be 4 solutions, since the highest degree is 4, and they give us a root that's an imaginary root. So by the complex conjugates theorem, we know that another root should also be -2 minus I. So notice that the -2 part doesn't change, but the positive I becomes a negative I. All right, so now what we're going to do is we're going to use synthetic division to try to break down this polynomial into a lower degree. So we're going to bring it down from a quartic to a cubic function. All right, so I'm going to use the first root that was given to me, which is -2 plus I. And just like you do normal synthetic division, you bring down the 1, you multiply, you get -2 plus I. So now you have to be careful when you add. You get 8 plus I. All right, and then we need to multiply that. So I'm going to do this off to the side. And we're going to do 8 plus I times -2 plus I. So that gives me -16 plus 8I minus 2I plus I squared, which simplifies to 6I. And then we know that I squared is equal to -1. So -16 minus 1 is -17 plus 6I. All right, so I'm going to put that in there. -17 plus 6I, and then I add that together, and I get 21 plus 6I. All right, now I'm going to repeat this process. So I'm going to do -2 plus I times the quantity 21 plus 6I. And we're going to multiply again. You get -42 minus 12I plus 21I plus 6I squared. So I combine my i's, I get 9I, and -42 minus 6 gives me -48. So I'm going to put that in here. -48 plus 9I. I add that to the 66, and I get 18 plus 9I. All right, so I'm going to multiply one more time, and I have -2 plus I times 18 plus 9I. And that gives me -36 minus 18I plus 18I plus 9I squared. All right, so if you notice, now we're getting to things that cancel out, which gives me -36 minus 9, which is -45. And this is a good sign because when we add this together, we get a remainder of 0, which is proving that -2 plus I really is, in fact, a root of the original polynomial. All right, so now what we need to do is continue our synthetic division. This is a cubic function, and we're going to use our second root that we know about, -2 minus I, and we're going to do synthetic division to get it down to a quadratic. So that gives me -2 minus I, and I'm going to add, and I get 6. This gives me -12 minus 6I. My imaginaries cancel out, and I get 9. Multiply, I get -18 minus 9I, and I get 0 as a remainder. So that proves that -2 minus I is, in fact, a root of the original polynomial. And then now I'm down to a quadratic, which this is x squared plus 6x plus 9. And this is factorable, so I'm going to factor that into x plus 3 and x plus 3, which gives me 2 more roots. So my final solution is find the other roots. All right, all of my roots are -2 plus I. They gave that to me. -2 minus I, -3, and -3. So just a few things to note. We're going to look at this graph on our calculator, but we know that when we have 2 roots that are in the same location, this is a double root. So on the graph, it should look like a bounce back point. Right? And then one other thing to note, that when you're factoring this quadratic, you could have used quadratic formula, which I think is the longest method. We could have tried to factor, which is what we did, and we could also try the square root method. But the square root method doesn't work if you have a middle term. Like since we had that 6x, we couldn't do that. So we went with the factoring method. All right, let's take a look at the graph of this polynomial to verify what it really looks like, and does it appear to have a double root as we suspect. So I'm going to go to y equals, and I'm going to type in my equation. I have x to the 4th plus 10x cubed plus 38x squared plus 66x plus 45. All right, so I'm going to hit graph. And remember, it's a 4th degree polynomial. I should have 4 roots total, but 2 of them are imaginary and 2 of them are real. And if you notice, at -3, the graph appears to go down, bounce back up right at -3. You can even hit trace and verify if you type in -3. That is a point at -3, 0. So that does in fact show our bouncing off the x-axis double root scenario. All right, moving on to the next problem. This time they give us 4 plus I root 2, which is an irrational and imaginary root. So we know that by the conjugate theorem, we should have 4 minus I root 2 as a second root. All right, this is a 4th degree polynomial. So instead of trying the same method that we did before with the synthetic division, I'd like to do a different method. So we're going to call method 2 the long division method. And I think that if you have something that will be difficult to do with synthetic division, we should try the long division method. We're going to call this method up here the synthetic division method. So how are we going to use long division? Well, we know that if we have these 2 roots, we can make factors. So the original quartic function should be divisible by x minus 4 plus I root 2 and x minus the quantity 4 minus I root 2. If I have a root, I can create a factor. I'm going to simplify this, so I have x minus 4 minus I root 2 and x minus 4 plus I root 2. And I'm going to multiply those together, so I'm going to distribute. All right, I'm going to multiply x times everything. So I have x squared minus 4x plus ix root 2. Then I'm going to distribute the -4. I have -4x plus 16 minus 4I root 2. And I'm going to distribute the -I root 2. I have -ix root 2 plus 4I root 2 and -I squared root 4. All right, so this looks lengthy, but we can simplify as much as we can to try to break it down to something more manageable. All right, so we've got some terms that cancel out. So I see, well, I do see things that can combine. So x squared minus 8x, so that takes care of these terms. All right, I have a positive ix root 2 and a negative ix root 2. Those cancel out. We have a negative 4I root 2 and a positive 4I root 2. Those two cancel out. We have an I squared, so that's minus negative 1 times 2. So that really becomes plus 2. And we have a plus 16, so that gives me plus 18. So after all of that, when I multiply, we've got a quadratic. All right, so now we need to use our long division method. All right, so let's go back to our long division. And we're going to divide by x squared minus 8x plus 18 from the original polynomial, which is 4x to the fourth minus 32x to the third plus 81x squared minus 72x plus 162. All right, so I need to divide, and when I do that, I look at really just the first term. So x squared times what will give me 4x to the fourth? Well, I know I need a 4 there. That would give me 4x squared, and I need a higher degree of x's, so x squared times x squared will give me x to the fourth. All right, so I need to distribute the 4x squared to the divisor. So that would be 4x to the fourth minus 32x cubed plus 72x squared. All right, so I need to subtract. So 4x to the fourth minus 4x to the fourth, those will cancel. I'm going to subtract. So notice I'm changing these to add the opposite. This cancels, and then I make that negative. So that gives me 9x squared. All right, I'm going to bring down all my remaining terms, and then I'm going to try to do it again. So x squared times what gives me 9x squared? Well, I just need to multiply it by 9. So if I distribute the 9 to everything, I'm going to get 9x squared minus 72x plus 162. And when I add the opposite of that, you'll notice, oops, this is already negative, so this will become positive. You'll notice all these cancel out, and the remainder is 0, which is great because if I have factors that should divide in evenly, I should have a remainder of 0. All right, so now I just need to look at, well, how do I solve the remaining 4x squared plus 9? Remember, we had our choices of we could try to factor. This is almost factorable. It's not a difference of 2 squares, though. It's a sum of 2 squares, so that doesn't work. We could do quadratic formula, but I always like to say keep quadratic formula as the last resort because that one takes the longest. Our last thing is square root method. And let's do that. So we've got 4x squared plus 9 set it equal to 0, and we're just going to subtract 9. So we have 4x squared equals negative 9. Then I have x squared equals negative 9 over 4. And I just need to take the square root of both sides. And I get x equals plus or minus. Now if I take the square root of a negative, I know that's going to give me an imaginary. So it's going to give me 3i over 2. All right, so my final answer, it was to find all of the roots. So my roots are, they gave me 4 plus I root 2. I came up with 4 minus I root 2. And I determined that 3i over 2 and negative 3i over 2. Those are my 4 roots. Last problem, number 4. Find a quadratic equation with rational coefficients with the given root. Write the equation so that the leading coefficient is 1. All right, they give us a root. So we know that the second root is going to be 1 minus root 6. All right, so I think the easiest way to do this is to use the factoring method. But we have another method we could also try. So we're going to work backwards. If I know that 1 plus root 6 is a root, then I know that a factor would be x minus the quantity 1 plus root 6. And then if I know that if I know that 1 minus root 6 is a root, then x minus 1 minus root 6 is a factor. All right, so let's distribute that negative sign, and then we're going to multiply our two quantities together. So I'm going to distribute my x. I get x squared minus 1x plus x root 6. And distribute my negative 1. I get negative 1x plus 1 minus root 6. And I'll distribute my negative root 6. That gives me negative x root 6 plus root 6. minus root 36. All right, so that gives me x squared minus 2x. These add together. I have a positive x root 6 and a negative x root 6 that cancels, a negative root 6 and a positive root 6 that cancels, and I have 1 minus 6, which is negative 5. All right, so it just said to write a quadratic equation, so I could put y equals x squared minus 2x minus 5. If we want to use function notation, let's do f of x equals x squared minus 2x minus 5. All right, so that I would call method 1. And then let's do method 2. So method 2 involves the sum and product of the roots of a quadratic. So you know that a quadratic is ax squared plus bx plus c. If we recall from algebra 2, the sum of the roots should be the opposite of b, and the product of the roots should be exactly c. So I know that my roots are 1 plus root 6 and 1 minus root 6. If I were to find the sum of those two roots, I would add together 1 plus root 6 plus 1 minus root 6. And I add those together and I get 2. So that tells me that I should have x squared minus 2x, right? I also know that a has to equal 1. All right, so opposite of b gives me this minus 2x portion. All right, and then let's find the product of our two roots. So the product is multiplying 1 plus root 6 times 1 minus root 6. If I distribute everything, I get 1 minus root 6 plus root 6 minus square root of 36. And my negative root 6 and positive root 6 cancel, and I have 1 minus 6, which is negative 5. So that tells me what c should be. So now I know that this should be minus 5. All right, and then I'm just going to put in f of x or y equals, and that provides me with my quadratic. So that is possibly a shorter method. You can choose whichever method you like, whether you go with the factor method or the sum and product of roots method. All right, and that is it for today.